Welcome viewers. In this video we will see the parameters of armature winding in a alternator. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In alternator, parameters of armature winding. There are three parameters available: armature resistance RA, armature leakage reactance XL, reactance corresponding to armature reactance XAR. In these three parameters, the first two parameters separate video available. The link is given in the description box. Now in this video we are going to see the third parameter, reactance corresponding to armature reactance XAR. Now we'll go to the diagram. So the third parameter, armature reaction reactance XAR. The effect of armature flux on the distribution of main flux is called the armature reaction. We know that there is a main flux as well as armature flux. So the armature flux distribution over the main flux is called a armature reactance. So due to that, what happened? The effect of armature flux depends on magnitude of current in armature, nature of power factor of the load connected. First one is armature current, current in the armature, and power factor of the load. So depends upon the load, power factor will vary. Let us consider the effect of power factor of load on the armature reactance. So we'll consider the effect of the power factor depends upon the load. So there are three power factor we are going to consider: unity power factor, zero lagging, and zero leading. First we will go to the unity power factor load. So due to that, what happened in the armature reaction? So first we will consider the unity power factor load. Pi F is the main flux responsible for producing the EMF E phase. So the pi F refers the main flux. E phase lags pi F by an angle of 90 degree. So there is a lagging of 90 degree between the EMF E phase and main flux pi F. E phase produces a current IA phase in armature. In a unity power factor load, E phase and IA phase are in phase with each other. Unity power factor, both are in phase. Both voltage and current in the armature and E phase are in phase with each other. So IA phase produces a flux pi A in phase with the IA phase. Already pi F main flux is there. Due to IA phase, another flux is produced, pi A, that is in phase with the IA phase. So there is a phase difference of 90 degree between pi A and pi F. There is a 90 degree phase difference available between these two. Therefore, the effect of armature flux on main flux produces cross magnetizing effect. Cross magnetizing means the effect will be reduces. It will cross each other. Right, now we'll see the diagram. So this is the main flux pi, this is the EMF generated. Already both are in 90 degree phase shift. So this is the pi A produces, that also in 90 degree phase difference between pi A. So due to pi F, this IA phase is produced. Due to IA phase, pi A is produced. Both are in 90 degree phase shift. So it is separately available, pi F and pi A with angle of 90 degree. So due to that, cross magnetize, it will cross each other. So this is the main flux pi. So it will start after 90 degree pi A. So there is a cross magnetization happen between the main flux and armature flux. So in the unity power factor, the effect is cross magnetizing. The pi F and pi A are 90 degree phase difference. So there is a effect of cross magnetizing. Now we'll go to the next type, zero lagging power factor load. Earlier unity power factor, now zero lagging. When it is zero lagging in a pure inductive load, the power factor is zero lagging. Right? We know that in case of inductance lagging, in case of capacitance leading. Pi f produces a voltage E phase at 90 degree lag. E phase produces a current IA phase. So that is the normal. Pi f produces E phase, that is already 90 degree phase shift. Because of E phase, IA phase is produces. For zero lagging, IA phase in phase with IA phase. Both are in phase. IA phase give you a flux pi A in phase with IA phase. So because of the current IA phase, pi A is produced, that is also in phase with the IA phase. Now the pi A and pi F are at 180 degree to each other, that is they are phase opposition. In earlier case it is 90 degree phase difference is there, here 180 degree, both are opposition. So the effect of pi A will be cancelled by pi F, both are got cancelled. So the effect of armature reaction is demagnetizing effect. The flux created by pi F will cancelled by pi A, both are 180 degree opposition, so that it is called a demagnetizing. Earlier case because of 90 degree cross magnetizing. See this is the pi F. Here the E phase is there, which is 90 degree. There is a 90 degree phase between pi F and E phase. Because of E phase, IA phase is created. Due to that, pi A is created. Armature flux. See, these both are opposite. 180 degree opposite. Both are opposite. So that this is the pi F main flux. The pi A is completely opposite. Negative of that pi F. So completely opposite. So both are got cancelled. So we got the demagnetizing effect because of this zero lagging power factor. In zero unity power factor, cross magnetized 90 degree phase shift, because here 180 degree phase shift, both got cancelled, demagnetization will happen. Now we'll go to the leading power factor. Zero leading power factor load. In a pure capacitive load, the power factor is zero leading. Earlier case, inductive load lagging. Now capacitive load leading. Pi F gives the voltage E phase at 90 degree lag. So that is already we discussed. There is a 90 degree phase shift between pi F and E phase. E phase circulate the current IA phase. For zero leading power factor, IA phase leads the E phase by 90 degree. So there is a 90 degree leading available between IA phase and E phase. IA phase gives a flux pi A, armature flux. Pi A is in phase with IA phase. In all the cases it is the same. Pi F and pi A are in phase with each other. Now both are in phase. Earlier case 180 degree opposite. Now both are in case. Because of in case, what will happen? We'll see that. So both are in phase. So the effect of armature reaction is magnetizing effect, added together, increased. Earlier case completely demagnetized. First case cross magnetized. Now it is magnetizing effect. See, this is the pi F and E phase, which are both are 90 degree. This pi F and E phase circulate the current IA phase, that will generate the flux pi A. See, both are in same direction. Pi A and pi F are in same direction, so that it is magnetizing effect. So this is the pi F, and pi A also in phase with the pi F. So both are added together. Earlier case completely opposite. Now it is in phase, that is it will be magnetizing. Both will be added together. So that we have got the magnetizing effect. So the first case cross magnetization, second case lagging, demagnetization, third case leading, magnetization effect. So due to armature reaction, there is a voltage drop. To quantify the voltage drop due to armature reaction, the armature winding is assumed to be having fictitious, that is imaginary reactance XAR, armature reactance reaction reactance. So we assume that we are assuming imaginarily, we are assuming there is a reactance available XAR, that is armature reaction reactance. Now we'll see another two parameters, armature synchronous reactance and synchronous impedance. So synchronous reactance XS is nothing but XL plus XAR. Leakage reactance and armature reaction reactance, both are added together, so generally it is called a synchronous reactance. Then what is the impedance? We have one more parameter, armature resistance. By adding armature resistance, we will get the synchronous impedance. So Z RA plus JS, this JS is nothing but XL plus XAR. In that, if you add the armature resistance, then we will get the synchronous impedance. The impedance obtained by combining the value of armature resistance and synchronous reactance is called synchronous impedance. ZS equal to RA plus JXS. So in this video we discussed the armature winding parameter. There are three parameters available. First two parameters separate video available. In this third parameter, armature reaction reactance XAR, we discussed with the three power factor: unity power factor, lagging, leading. So unity power factor we have cross magnetization effect, lagging we have demagnetization, completely demagnetized, third one magnetizing effect added. So that we are assuming that imaginarily we have XAR is available in the armature circuit. And also we discuss synchronous reactance and synchronous impedance. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.